Hello, hey everybody. Hopefully everybody can hear me nice, loud and clear. And welcome to my session on migrating a data capture solution with event hubs and stream analytics. So we're going to cut straight into it because of a lot of content to get through. Um, a big call out to our sponsors. Without their support, these events don't happen. So it's greatly appreciated. And particularly now when we're running things online, give them a little bit of love, call over, see what type of things they have on offer in there. You never know when you find some of the products and services they sell will actually be something you'll be looking for. So a little bit about myself. My name's Mark Hayes. I am a Microsoft MVP in the data platform. My contact details are up there. And basically, by way of background, I've been working in the Microsoft data platform in some shape or other since around the year 2000. So, 20 odd years of it at this stage. A lot of business intelligence type of work during that time, a lot of data warehousing, a lot of services, more recently, obviously, Power BI, Power Platform, integration services back in the past and still currently today. So, fairly long history with the Microsoft stack. So all of my demos, I like to set up a business requirement around it, right? I feel it helps to kind of make it to set what we're trying to achieve. So I'm actually going to bring you back a few years, several years, where a company approached me with a need to create the following. They basically were selling a system that used to capture your phone MAC address as appeared in Wi-Fi routers. And then if you have one of those installed in a shop or a premises, you can basically get statistics out like people passing your shop, how many people pass the shop versus visit, how long do they stay, how frequently. Essentially, you can calculate dwell time, loyalty, footfall. They also wanted the ability to maybe react to some live data coming in there as well. Okay, so then it was another kind of requirement they had. Now, way back then, before we had to try to do this in Stream Analytics, it was kind of pretty much an infrastructure as a service solution where you had a router and then we wrote a web service to receive continuous data coming in from a router. You're passing that data into packets down onto your file share, and then you have integration services is then churning over those files to load it into a SQL database and then start creating your reports. And that was all done in IaaS with FTP service having to be configured, IaaS, operating systems, patch management, all that kind of stuff in there. Quite a lot of work actually required to kind of build that solution back when we had to do back in 2012, 2013. So what would that look like today? All right. We will now begin with today, we call that a stream and capture solution, okay? Because the data is arriving all the time. They want to process it. They want to do some analytics on it when it arrives, particularly for the whole react to live data side of things in there, okay? And this is one of the V's of big data, all right? It's the one in bold there, the velocity. So data that's continuously arriving on top of you and you need to perform some analysis. Different from batch. Batch is it arrives and later on you're doing some of the bit of processing on it. But it's the fact that as it gets in there, you're reacting a little bit to that data is a differentiator here in terms of how you want to have a streaming solution work. So velocity, the speed at which data is generated, data arrives continuously, and you want to perform analysis on it. What would that solution look like today? So I still would have a router involved in this one because it would still be sending data somewhere, except this time it's sending it into something called an event hub. The event hub will pass it on to something called Stream Analytics, or I suppose more correctly, the Stream Analytics job will take it from the event hub. And from there, we can put data into an Azure SQL DB, and of course, we would put Power BI or something like that in front of it. And all of this would now be managed platform as a service up in an Azure. What I'm going to be talking about centers on these two components in here. So here's my event hub, which basically is a web service that receives messages, and stores them. It stores them for another service downstream of it, Azure Stream Analytics being one of them, to actually take the data. So a message arrives in here, it's retained here, another service upstream goes, give me your messages, and it starts working on it. So that's where we're going to be doing our little bit of focus on. So let's have a quick little demo of actually what we build behind that before we go a little bit further, okay? So this is my Azure Blade, okay? There's a couple of things over here we're going to have a quick look at. Well, I'm not really going to look at the database. It's a database. It's sitting up there. It's a basic database inside my demo tenant. I then have got an event hub set up in here, and then underneath it, I've got a Stream Analytics job, okay? Just by way of showing you that the data coming in is live, I've got a C# program here running in the background, and it's sending lots and lots of messages to my event hub at the moment. Okay, so let's go back to my database. The net result of all of this is, if I go running a quick count over that table, I will see, I'm going to guess, around 500,000 rows of data in there at the moment. That's fine. So that's what we're seeing in there at the moment. If I have to look at the contents of some of that data, let's just get a quick glance at what I have. So I'm mimicking a MAC address at the moment in here. Okay, so what I'm reading down here is, well, here's a scene time, data arrived at. This is my access point that I'm simulating. This is my MAC address that I'm simulating. And then over here, I've got a classification of that MAC address as to whether the algorithm thought that it was a visitor to the premises or a passerby to the premises. And you can see in here in the way it's set it up at the moment, it's seeing most people as a visitor, but it's seeing some people as a passerby. It's a very basic check. If I see them more than 5 times in this one, I classify them as visitor, or sorry, as visitor, and less than 5 times they're passerby. So that's kind of what I'm capturing, and that's one of the outputs of it. I mean, that's taking the data from streaming messages to very, very concrete sitting in an Azure SQL database for me to do my analysis on. Let's see, has more data arrived in since? Let's run another count. And we can see in there now, so another 25,000 rows of data have been added on into my table. And if I try it again, roughly about every 20 seconds, it will do an update in there, and we can see there's another update in there again. So another 8,000 rows have just appeared just while I've been talking here. Okay, so we can see that my data, which is coming from my C# program over here, is being processed somewhere, and it's getting into a database. Okay, let's look at the little bits in the middle of that. Back to my blade, go to my event hub, and this is my event hub. So in its essence, a web service that can receive messages. And we can see in here how it has been receiving messages for the last half an hour or so whenever I turned it on. Okay, so that's the reading. And before that, the event hub was on, but there was no messages being received in there. So a little bit basic view of, I can just see, okay, well, that's what's coming in. Clearly, there's stuff arriving into my event hub. If I go over to my Stream Analytics job and have a look in here, the Stream Analytics job, kind of 3 key parts of it. There are a few other things we'll talk about, but they're listed over here, where I have an input, I have a query, and I have an output. Okay, so my input is, where does my Stream Analytics get its data from? Okay, an Azure service that it gets its data from. My query is, what does it do? What type of query does it run over that data? And my output is, where does it put that data to? So if I was to look at my inputs at the moment, I can see there's actually 3 inputs set up in this job, although I'm only using one of them. Okay, I can click in here to have a quick view with more. All of these are event hubs at the moment. What I'm actually going to go do is I'm going to stop my job now. Okay, stopping the job takes a short while, but I can add on different types of inputs in there. I'm going to an event hub, which you can also pick up from different parts. You can pick it up from Blob in different areas in there. We'll see where we can do it in a minute. The output, again, visible down here. There's only one output up here set up at the moment. It's a SQL database, and over here is my query. If I go down and look at my monitoring side of things, what it is, I clicked in the wrong places there. If I look at the monitoring, you can see that just as we saw in the event hub where we had data coming in continuously, we can see the Stream Analytics job, since I turned it on, has also been receiving data continuously. And over here, here's a resource utilization, which is basically how busy my CPU is. And you can see here, it's sitting pretty much in a flat line somewhere between 20 and 25%. So, you know, comfortably handling the volumes of data that are going into it at the moment. Okay. So my job is stopped now. So I could turn around and say, well, let's look a bit closer into my inputs. And I can turn on, these are the type of inputs I can put into it. Okay, I can pick it up from an event hub, IoT hub, or blob storage. There's also an additional option where I can add in reference data. So this will be if I'm getting in data from my event hub, and then I want to look up something from SQL database and kind of go, okay, I've got this department code coming in here, and I want to join that department code to some data that exists inside in a data warehouse somewhere. You can actually, that would be viewed as reference data that you would need, and this is a way of just setting up that actual reference input so you can then reference it to it in your query. On the outputs, if I go looking at my outputs where I can put data to, I've got quite a good few options. I'm obviously using a SQL database at the moment in there, but there's also blob and table storage, service buses, Cosmos DB, Power BI, Data Lake, Azure Synapse. Okay, so quite a few places you can actually end up loading the data to in your sync environment. Again, I'm just using the database. And now let's look at the query. And here is where all the processing happens. So this is the query that has been running as part of my demo, okay? And we're going to look at this in a little bit more detail. It throws up underneath a preview of data that is actually received. So this is live data. It's kind of going, well, here's some live data, okay? Which basically means that I could then turn around and kind of go, okay, I can go test in this query. We're going to look at this a little bit closer in a minute, so I'm going to go a light touch on this right now. But the basic makeup of it is, well, I'm selecting data. Where am I selecting it from? Well, I'm selecting from something called console source, okay? If I just jump back out, console source is that input, okay? So I can essentially almost treat my event hub like a table, all right? In SQL world, it's like a table. So I'm selecting data from console source, and down to my query again. What am I doing with that data? Well, I'm doing some basic aggregation of that data, and then I'm putting it into Stream and Sycamore Stream Analytics demo. Okay, so that is a reference to my output. So that SQL is acting as the glue between the actual event hub and the SQL database, and saying, get stuff from my event hub, put it into this database. While I'm doing that, do a little bit of analytics on top of all of that. Okay, so that's the basic makeup of a stream analytics job. Let's go back to PowerPoint for a couple of seconds. Okay, so we had a look at the demo. A key concept when you're dealing with streaming data is the concept of window and functions. Okay, basically it's analysis of streaming data involving the segmentation of data into temporal windows, which is very sci-fi sounding. Basically, it's a way of grouping events over time. There's a few different windows you can have. There's a tumbling window, a Hopin window, a sliding window, a session window, and a snapshot window. Okay, so we're going to have a look at all of these. The next set of images that I got that are you're going to see all actually come from Azure Microsoft Docs documentation, so you can reference them there. And they decided to try to explain them via tweets. So first of all, we're going to have a look at the tumbling window. Imagine if you were doing a scenario where you wanted to count the number of tweets every 10 seconds, okay? So this might be your tweet stream coming in here. Tweets happened here, tweets happened here. A few seconds later, some more tweets happened, more tweets, more tweets. If you're looking at that in a 10-second tumbling window, this is what it looks like. It starts at 0, and after 10 seconds, it does a snapshot back of that's what's happened in this 10-second window. Then it starts a new window, which is going from 10 to 20, and it grabs, well, this is the output of that window. And here's another window from 20 to 30, and it grabs, well, these are the tweets that happened, so these are the contents of my window. So that's the tumbling window, quite a straightforward one. Then get onto a Hopin window, which could be a case of I want to count the number of tweets in the past 10 seconds, but do that every 5 seconds. All right. So looking in here, it starts off the same as before. I've got my same tweet stream. Tweets start off, and at 10 seconds, the first window kicks in, and it looks back 10 seconds and goes, well, that's what's in my window. But then 5 seconds later, which is my every 5 seconds part, it kicks in again and looks back 10 seconds. And then looks back more 10 seconds, another 5 seconds later, looks back another 10 seconds. So a tweet can exist in multiple windows, whereas in the first example, every tweet was unique to its own window. Let's have a look at the sliding window. Count the number of tweets that arrived in the past 10 seconds from when a tweet arrived or is past 10 seconds ago. So this gets a little bit busy. So here's my tweet stream. Okay, so start at 0. At 10 seconds, a tweet happens, which means a window becomes active and it's looking back for the past 10 seconds, and there's one tweet inside in that window. Then a few seconds later, another tweet arrives, which means another window kicks in, all right, and it looks back 10 seconds to see that, okay, now there's now two tweets within this window. We move forward again, 15 seconds later, another 2 tweets happen. Now there's 4 tweets in my window. But now what happens over here? Because at 20, another window's kicked in, but no tweet has arrived. But what has happened in here is my first tweet that happened at 10 seconds has now fallen out of the window. So this has kicked off another window. And well, we can see that there's 3 tweets in there. We keep moving forward. In here, again, no tweet happened here, but a window kicked in. If we follow back, it's because our 5 seconds has popped out, or tweet number 5 has fallen out of the window. That continues at 8 when a tweet arrives. So it generates a new window, but it looks back and those guys will come out of it. And then eventually at the end, that's actually the last tweet. And 10 seconds later, another window kicks in, indicating that 8 has now fallen out of the window. So quite a lot of analysis going on inside in that window in there. There's then a session window. For some reason on the Microsoft documentation, they were doing the whole seconds and then they changed the minutes. So I just ran with it for now, right? Count the number of tweets that will happen within 5 minutes of each other over a 10-minute period from the first tweet. In a window, this is what happens. So after a minute, a tweet happened. So a window opens up, okay? Because something happened in here and over a 10-minute, and this is within a 5-minute period. So what happened within the 5-minute period? Well, another tweet arrived. So then it continues on a bit further until eventually the 10-minute period happens and it drops out. So it's defined one window there. Then there's a period of silence, another tweet kicks in which case our window now starts building because another tweet arrived, another tweet arrived, another tweet arrived. They all kept arriving until eventually the 10-minute timeout happened and we close it off. So in this window, my window actually has got longer than my initial period of 5 minutes. It's expanded in time, okay? And then similarly, we get another one over here where a tweet happened. Okay, so we're into our window, and then 5 minutes later, the window closes off because, well, there's been no more activities happening there. So this is a case of there's more clustering of data. It's like it's picking up clusters of tweets in here, like a bunch of activity happening around here. So let's watch that activity. If the window's got to grow, we'll keep growing it until the activity seems to end, and then we'll shut down our window. And now we'll wait for a new window to open up. And then the last type of window is a snapshot window, which is basically count the number of tweets that happened at the same time. So a very, very specific window going on here represents a different way. Looking over in there, count the number of tweets at the same topic that happened at exactly the same time. So a bunch of tweets happened here at this time, so that's the window. A bunch of tweets happened here, that's the window. That's the window, that's the window. So just bang, something's happened, grab the window. Okay. So that's a little bit of talking about windows. I'm going to go in and demo that a little bit more. So I'll just pop into here, going to edit my query. I want to get sample data. So I have sample data in here. This is actually real data that's coming in from my event hub, but I'm actually going to upload a sample file. And why would you do that? Because, well, when you're building a solution, you might have kind of sanitized data that you're kind of going, well, this is the type of data that's going to come in, and I know how I want to analyze it. I know the type of results I expect. So it's kind of clean. All right, so in the same case, I've got my demo data here. I'm going to open that up. Go OK. Great. So let's just look at my data for a second. And it's very simple. I've only got, what, 6 or 7 rows inside in it. And if we pay attention here to my seconds, or my minutes and seconds, and this is my simulated max. So 1-1. So 1-1 happened at 41 seconds, and then a few seconds later at 46 seconds, 1-1 appeared again. A few seconds later at 49, 1-1 arrived again. A few seconds later, 1-1 arrived again. Then about a minute later, exactly a minute later, I saw 1-1 another time, okay? And then up here, again, a minute or two later, or slightly different time frame, I saw 1-2, and 2 seconds later, I saw 1-2 again. So if I was to try to look at that set of data, and if I was doing my visitor passerby analysis on this one, we might decide that I think these 4 read-ins was all basically a period when a user was in my shop or in close proximity. And then this one that was a minute later, okay, I don't want to classify that. Maybe he just walked by the shop at that point in time. Okay, so I kind of go, well, I view this guy as a visitor down here, and then later on as a passerby. And then this person up here clearly wasn't a visitor because my basic requirement is going to be I want to see him at least 3 times, right? So that's kind of my head analyzing that rows of data, saying, okay, that's what I have. But what would we get out if we went into the query? So I'm going to go into my query mode. So I'll comment that guy out. Okay. And I'm going to start here with my tumbling window. Well, the tumbling window basically is, so I'm back in seconds mode in here. So I'm creating a tumbling window in every 10 seconds. Okay. So I'm going to go run and test that query. And it will take my input data, run it through it, and show up some results. Hopefully very soon, because normally it only takes a couple of seconds. There you go. So let's look at how I'm analyzing it. It's very simple. As I said, if I see it more than twice, it's a visitor. Otherwise, they're a passerby. Okay. And if I look at my stream in there, I would kind of go, okay, let's read what happened. Well, up at 40:50, it saw me 3 times. So it's classifying me as a visitor, okay, which I would agree with. But then a period here at 41:50, so that was the period, that was the read, and that was a couple of seconds after the minute. It's got a different window going on. So it's classified him into a different window. So therefore it's a passerby because there's only one of them. This person never meets the criteria because he's only there twice, but it has correctly classified as a passerby. And then the minute later read-in, it just sees once and it goes, that's a passerby. So close, but not quite right, because we're kind of saying, well, actually, I would group all 4 of those lines into the one area if I could. All right. So that's my tumbling window. Let's move on to the next one, which is a Hopin window. So remember the Hopin window, it would look back every 10 seconds, do that every 5 seconds. Okay, so let's run that query. And now I'm getting more rows of data to begin with, okay? And starting at 45, and then 50, then 55, then a minute, then it jumps on to minute 15. So if I look at what's I'm reading in here, well, it basically saw the visitor, it saw the read and says, oh, you're a passerby. And then 5 seconds later, it read it again and go, oh, now you're a visitor. But then 5 seconds later, it looked back another 10-second window, still saw the 3 appearances, so reclassified as a visitor again. And then draws off the passerby. Then number 2 arrives in, and he's seen as a passerby twice because he was in 2 windows that were 5 seconds apart, and then passerby. So clearly, I'm overanalyzing in here. I'm capturing more data. It's the same amount of data, but my analysis has produced more rows out of it, which is what I don't want in this case. So I'm going to close that one off. Let's look at sliding window. So this is counting from when it enters or exits the window. No, I don't have to select. I think it's wrong. So we go run this. And now I'm seeing lots of rows of data. I'm now actually seeing more output rows than input rows going on here. I like to think of the sliding window as very shouty. Okay. It's like a guy standing outside my shop kind of saying, there's someone coming, he's still coming. Oh yeah, he's in the shop, he's still in the shop, he's still in the shop, they've left. You know, there's an awful lot going on here, right? Because there's lots of windows being created because there's lots of events happening. So to begin with, he entered the window, so classified as created a window, did it count as passerby. Then seen again, so another window pops up, did it count passerby. Then seen a third time. So now another window is generated. This time the window, they classify him as a visitor. But then the first one event drops out in this window. So suddenly this person is back down to passerby. And then another appearance happens. So within that new window, back up to visitor. And then all the rest of them are passerbys. So really very, very verbose amount of data being thrown at you as that goes on in there. Which again, from my analysis, is not what I'm looking for. Okay. So let's do this. This is a session window. So the session window is the one where Person comes into the window, extend out the window while I still see that event go happening, and then stop the window. And this looks much more interesting, okay? Because now I got 3 lines of output. There's a window here generated at 05, and if I look at the count to begin with, it's 4. So clearly it's gone past my 10-second window in here, but within that it extended it out and said, well, I'm still seeing this reading, so I'm going to extend my window until eventually the window closes. Okay, and now that for me will go, yes, that was what I would correctly consider that cluster to be a passerby. In the meantime, they'll change to 1.2, still a passerby. And then the instance of 1.1 that I saw a minute later, I'm saying, yeah, well, that was a passerby because that's how I decided to set up my analysis in there, and he still falls the passerby. So this one looks like the one that I should be running with, right? I mean, this is good. There is one more I want to show you. This is a snapshot. The snapshot was relatively new, so I actually only wrote this query a few minutes ago. I hope it works. Yes. Okay. So the snapshot, remember the snapshot is basically how many, something happens, create a window, basically what's happening right now. So really actually all of this is outputting in my case is just outputting the exact same rows as it got in, because all the events happened on a slightly different timestamp. So each one is its own little window with only one person inside in all of those windows. So everyone's going to be classified as a passerby, and there's only going to be one person seen within that window. So that's the snapshot view. Something happened, that's my window. Okay. Cool. So they are all of my windows explained in here. What I'm going to do now is I'm going to go back and I'm going to save this off, and I'm going to turn on my Stream Analytics job. So even actually just kind of interesting, when I turn on the Stream Analytics job, I get a couple of choices in here. Do I want to turn on from now or when last stopped? So while I've had my Stream Analytics job turned off, I've still actually been receiving a lot of messages into my Event Hub. Okay, so where are those messages going? Well, right now they're going nowhere other than into the Event Hub. Remember, we said the Event Hub is a place that can receive messages and store them until they're acted upon. Okay, so at the moment the Event Hub is just storing up messages. Okay, I can now turn around and start up that whole Event Hub in there again from now or stopped if you want to play catch up. So you basically could do the whole, I have to make a change in configuration to my Stream Analytics, turn them off, do my work, gone. There's no loss of data coming in. I'm just going to kick it off from now again. So that will kick off now. So let's pop back to my PowerPoint. Okay, let's talk a little bit about costs. There's a light touch on costs. The database side of things I'm largely ignoring. Okay, I've just got a basic €5 a month database on here at the moment. If I look from an Event Hub point of view, there's basically 2 flavors. There's a basic and there's a standard. So the basic is €9, the standard is €18. They charge that per TU, and you can have a max in TUs, 20 TUs on an Event Hub. A TU is a throughput unit. Okay, it is a measure. We'll look at that measure in a minute. They also have a dedicated variety, which is 5,000, nearly 5,000 a month going on there. They also charge for ingress events. It's pretty small, but you do have to note it in there, depending if you have a lot of events going on. On the Stream Analytics job, there is a standard and dedicated. If you go dedicated, it gives you a minimum of 36 streaming units, which is again another unit of measurement. If you go standard, you can start from 1 and go up to 192. All right. Each streaming unit costs just over 10 cents an hour, which is going to work out into around €75 a month. Okay, you can go up to 192 streaming units. If you did, that would cost you about 15,000 a month to run. So let's talk about performance and scale. 3 key areas: Event Hub, Stream Analytics, Azure DB. Again, I'm not going to talk about the Azure DB side of things in here. Okay, I'm going to look at the first 2. So if I go looking at Event Hubs, we get a namespace here, which you set up the basic and standard, and there's some differences between them. The basic is basically the number of connections and consumer groups that can consume it. I'm going to have to skip over some of the more detailed stuff in there. One bigger call out in there is the message retention. So on the basic, I think it's a 1-day message retention, whereas on the standard, you get a 7-day message retention going on. All right, and also additional options to capture it up to storage. You can change this, however. If you start in basic and find that you need standard, you can just switch it. And then within all of these, you set up a number of partitions, which you go from 0 to 32. And it kind of depends upon your downstream concurrency that you have to set up. It's one of the only things in here you can't set up, you can't change dynamically going on. And then let's talk about the number of throughput units, 1 to 20. The throughput unit is 1 megabyte or 1,000 events per second. Okay, you can change this manually, or you can set this to auto-inflate. Okay, so if you had something that you said, look, I'm going to be setting up a service and I'm going to be receiving roughly around 5,000 events per second, then clearly you're saying, okay, I'm into 5 TU territory straight away. Okay. Or if you're saying, oh, I'm going to be, maybe I'm not receiving that many messages, but each message is really heavy because there's an image in it. So I'm going to be consuming several megabytes a second. Again, you're going to have to more TUs to consume it. Look at the analytics time, streaming units, 1 to 192. They define this as a unit of CPU and memory. Each SU can roughly process 1 megabyte a second. However, SU efficiency is affected by, well, lots of things. The windowing functions and the cardinality of data. So sliding window, tumbling window, Hopin window, they're all got their differences in terms of how expensive they are. Plus the data you're looking at, if it's very, very high cardinality into it, it can be more expensive to do the analysis on top of it. Okay. If you've got complex query joins, I mentioned there that you could say you're dependent actually on your message coming in. If it's like some complex JSON stuff in there, you could be doing a lot of joins just to actually get your data out of that message, which can increase the number of SUs you need. How many partitions you have and the balance between them in SU can affect the number, can affect the SU efficiency. If you have functions, I skipped over functions. I'll try to get back to them. But basically, a function is a way of saying, I've got data coming in, so Event Hub, sending in my data. My query is analyzing that data. My sink is storing that data. But maybe as part of my analysis, I want to call out to some other part of the Azure ecosystem, like say cognitive services. If you wanted to kind of run something through a cognitive service algorithm to kind of go, is this fraud or not fraud? Then that's a call out on a function, and that also affects SU efficiency. And then finally, the use of reference data, if you're bringing that into your stream in there as well. So all of these affect SU efficiency, which is why when you hear it initially, well, if one SU can process roughly 1 megabyte a second, and it can have a maximum 20 TUs, and each one of them can process 1 megabyte a second, surely I only need 20 SUs, right? No, you might need a lot more than that, depending on what you're going to be, depending on complexity of your query. So demo. So kind of actually covered this off a little bit, but let's just flick back to it, check my time. Yeah, I'm doing good. So let's go back to in here. So the basic way of looking at it in here is just reading off on these monitorings. Okay, kind of going, okay, it's giving you a sense of how many events are kind of coming in. I'm seeing my resource utilization. So clearly at the moment, I would say, well, how many SUs have I got set up in here? I think I've just got to 1. I've gone blank for a second. Scale, thank you. If I go looking at scale, you can see I can't change it at the moment because I am running, but that's okay. Remember, you can turn off your stream and analytics job, make your changes and turn it on again, and then set it to pick up from when I last stopped it. Okay, so at the moment I'm setting on a very basic scale of just 1 SU is running inside in here. Okay, so that's that. And if I was to look at that, well, clearly I'm consuming around 20% of that SU, so I'm well within my capacity. Okay, I'm comfortably handling the volume of data coming in here on a single SU. I can go back to my Event Hub, and on my Event Hub side of things in here, here comes my data, and I have got this set up. Actually, I previously changed this to 4 units onto it, so I'm taking in quite a bit of data in here. All right, but again, you can do your kind of maths and kind of going, well, is that flat line representing the fact that there's no more data coming to me and there's a bit of a buffer, or are we good? And you can actually see it down here when I can see, look down here and kind of going incoming requests and successful requests. And actually I got 0 on the throttled in here. Okay, so this is actually set up to handle the volume. If I save this back to 1, I'm skiing a little bit off piste here now and trying to go put change in these units. That should be saving. Just give that another minute to run. Oh yeah, sorry, it's done it. So what we should actually start seeing to happen now, we'll check back in a while, is I don't believe I've now got enough TU capacity to handle this. So we'll probably actually start seeing an increase in throttle requests shortly. Let's talk through a couple of PowerPoints, because you can't really show all of this one in a demo because they're stopping and starting a lot of things in there, right? But I ran a few tests to give you an idea. So in this first test in here, I'm looking at my SU utilization, my stream and unit utilization, and I'm sending in, I'm going to use 10 concurrent events and sending in 100 minutes and sending in 100 messages every second, okay? And I was doing a copy, i.e. copy operation was I actually had no tumbling window. I was just taking the data, put into the database, okay? And if I look at my SU, I can see it was barely hitting 15%. Then I sent in the same volume, 10 by 100 by 100, but I changed my window to a 10 second with a 20 second max, and you can see my SU, my CPU went up a little bit, okay? And then over here, I changed this to 10 by 100 by 100 send, by 100 sends, changed my sliding window to 5 minutes with a 10-minute max, so as opposed to 10 seconds, I went to 5 minutes. And if I look down here, I can see that again, my resource utilization is now heavier again, okay? I mean, still comfortably within my SU, but different from down here. So depending on what type of query you got going on, you're going to be consuming more SU. And then I set up another one where it says, okay, look, let's just run it on a longer window again, 30 minutes with a 60-minute max. And this is the type of record I got out of it. And I can see it growing up the whole time. And that's basically almost hitting an 80% point in there. So in this situation, if my requirement was to be having windows of 30 minutes or 60 minutes max, or say if that became an hour and 2 hours, then you can only get the sense of, okay, my SU, my single SU is beginning to get a bit of a problem here now, and we will actually hit a limit. If I was to look at those same queries from the messaging throughputs on the Event Hub, so here's my initial copy, and actually if you look down here, here's the corresponding result of that one, which was the incoming events and outcome events. Sorry, I'm still looking at my streaming analytics view of incoming data here. And then I started changing things, and you can see, well, here's my data coming in and my corresponding data getting written, going out. And there's kind of an interesting thing here is there's kind of a big spike up and drops down, and a big kind of flat line going on. And actually what was happening in that case was I was hitting a limit, as in the single TU wasn't able to take all the data, so there was a limit on how much could pass into the streaming unit. So starting to stress this, 20 concurrent messages, 200 messages, sliding window of that. This is my pattern I get now. Okay, so I'm up around the 50% area when I start doing this. So again, I'm kind of comfortable in there, but I can see that there's a flat line going on with my monitoring. And if I look at how much network activity was happening, that's what I was sending out to the network. So when I increase that to 4 TUs on a 1 SU event hub, these now start getting a higher resource utilization. My streaming unit has gone up to 95% now. My monitoring also increased up. So there's more messages now hitting my streaming unit. Basically, there was a bottleneck on the TU, so it wasn't sending enough to make the SU sweat. But then when we upped the TU, there was now more data to be sent out there. So now the SU is working harder to start processing that data in. But we can see in here now how I had doubled my network output as a result of doing that. And then you up it to some more data, and basically you kind of see more of the same pictures begin to happen in here. I think the call out in here is, as opposed to the specific in and outs of this, all right, here was my incoming data. I upped to 3 SUs. My SU efficiency had gone up to 80% utilization. I turned it off or reconfigured, and then you can see in here, okay, while it was spiking up to 80%, it then drops down, spikes up, drops down, spikes up, drop down. So not kind of flatlining out up there either, all right? So there's a bit more room inside my SU now, capacity to handle the volume. And interestingly enough, even more messages started coming in as well. So the combination between having gone up to 4 TUs of sending the data and increasing the SUs meant my SUs could consume more data to get even higher message output, and still doing it within an acceptable load performance of spiking up into 80. So there's and network utilization went up a little bit higher, not radically, but a little bit higher. So basically, we're looking at a lot of it. It kind of comes down to kind of case of reading the monitoring logs in here and kind of going, okay, you know, where am I seeing flat lines? Where am I seeing my spikes? What's the type of utilization I want? What type of overhead do I want to put in there? And then trying to fine tune around that. If I go back to my job in here, if I do a quick repage on that, am I going to see throttle events? I'm not sure. Maybe I wasn't sending the full volume. So actually, no, it's actually still able to handle things in here. Oh, okay. There's some throttle requests that started coming in there. So we could read that, and I can see I kind of tailed down a little bit going on. So yeah, I definitely seem to be getting some little bits of issues happening in here. So last slide, I think. There's a reference architecture document out there, which is based around 1 billion events a day. Right, and it's an interesting blog to read. If you break down 1 billion events a day, that's 700,000 events a minute, 12,000 events a second. You probably would want to allow for a peak time, so maybe a 1.5 multiplier. So you're looking at roughly an 18K event capacity a second is what 1 billion events a day looks like. Which if you think of from a TU point of view on your event hub, can go, well, we can handle 1,000 events a second. So 18 TUs for 18K. Let's assume each message is 250 bits, 18,000 events a second would give you, say, 4.125 megabyte a second coming in. Okay, so we're going to ram onto 18 TUs. That will comfortably handle it. But if we think about it from the SU point of view, you kind of go, well, each SU is 1 megabyte a second. So at the very least, I need 5 SUs to consume my 4 megabytes a second. But then I also have to allow for query type and scale. So you would probably actually start with 6, like all things that start small and expand it, okay? And that's from the blog, kind of going, yeah, we'll start this with 6. Each SU, there's also recommendation in terms of partitions. Each SU should have 1 partition, so they would give it 10. That sounds a bit contradictory. I think it was 2 partitions, actually. I think that's my error. But if we read this out, if we look at this, we would end up with something like this. My event hubs, there's my 18 goals. There's my streaming, my 6 SUs set up, and maybe I'll put into a database, so I'll put into a database. And if you're to cost that, you're talking $422 a month to run that number of event hubs, and $525 to run that number of stream and analytic units. Of course, it depends. Okay, it depends on how heavy those queries are inside your streaming units. Maybe when you set up your reference architecture, because of complex joins, you find you need 12 SUs or more SUs. And this is where obviously the whole tuning of things is there ways I can simplify stuff so you can get your costs back down. But it's an interesting read, this blog, about the whole way how you could actually still get an architecture up and running in PaaS that could handle 1 billion events a day coming in for something that costs maybe $1,000 a month to run. Summaries and conclusions. Compared to what I started with, which was a real requirement that came to me, and to consume data this way, and we ended up building an IaaS and putting lots of services into it. I mean, this is a far, far simpler way of doing it, okay? Capable of building a solution that can handle 1 billion events a day and more. It's quick to build. I mean, there's only real dev involved in this is the stream analytics function itself, all right? The SQL query that you're basically putting in there, okay? Certainly easy to scale and cost per unit, again, 1 to 20, 192. Obviously, if you're putting into an Azure database, there's lots of ways you can price up Azure databases, okay? So the call out for me, I mean, that's what's the takeaway for me on this one is, I mean, it's straightforward. I mean, it's one of the great things of PaaS. It's easy to spin these things up and to test them out. And with the stream analytics side of things, if you do a little bit of math, basically, you should be able to do your analysis of how much resources you need. Okay, that's it for me. That's my session. Thank you very much, Scottish Summit. I think I'm 2 minutes ahead of time, which is great. I hope my fast-paced Cork accent, which might need subtitles for some people, didn't confuse you all. And thank you for turning up.